Welcome to Part 2 of Formulae and Inclination, an investigation. You will use numerical values to derive and explain all the facts and formulae yourself. Be practical, use your sketch and your own observations. Learn when formulae are needed or not. Let's do an investigation where we highlight 3 cases of straight line graphs: vertical and horizontal lines, lines through the origin, and lines through any 2 given points. In each case, we will determine the distance, the gradient, the midpoint, and also the equation. First, investigate the situation. In case 1, we have vertical and horizontal lines. In 1.1, the x-coordinates have the same value, and therefore the 2 points are beneath each other, and we have a vertical line. In 1.2, the y-coordinates have the same value, and therefore the 2 points are alongside each other, and we have a horizontal line. In each case, by inspection, write down the length of PQ, the gradient of PQ, the midpoint of PQ, and the equation of PQ. Pause while you do so. Pause to mark your answers. The major question here is, did you use or need any formulae? Rather, observe the sketch, apply your own thinking, and just write down the answers. Let's take a look. The length of PQ. In both cases, the length was 4 units. In 1.1, that was the difference between 7 and 3, the vertical length, and in case 1.2, it was the difference between 6 and 2, the horizontal length. The gradient of PQ. The gradient of this line is undefined because it is a vertical line, and the gradient of this line is 0 because it is a horizontal line. The midpoint of PQ. Well, we realize the midpoint of PQ would have the same x-coordinate as P and Q, therefore 2, but the y-coordinate will be the value halfway between 3 and 7, so it will be the 0.25. The midpoint of PQ in the second case will have the same y-coordinate, namely 3, but the x-coordinate will be halfway between 2 and 6, and therefore the midpoint will be the 0.43. The equation of this line is x equal to 2, because x equal to 2 is a fact true for every single point along that line, and the equation of this line is y equal to 3, because that is true for every single point on that line. Case 2. Lines through or from the origin. Note the coordinates of the points in each of the 4 cases, and then note the horizontal and vertical, the horizontal, the vertical, the horizontal, the vertical, the horizontal, the vertical, all those lengths. As for case 1, we will by inspection write down the length of OP, the gradient of OP, the midpoint of OP, and the equation of OP. Pause while you consider your answers to these questions. But think carefully before reaching for any formulae. Rather, observe the sketch, apply your own thinking, and then just write down your answers. Pause to mark your answers. Now pause to study and explain the answers. Once again, did you use or need any formulae? Let's consider the answers. The length of OP was 5 units in all 4 cases. Applying the theorem of Pythagoras, we discovered that we had a 3-4-5 triangle in each case. The gradient of OP. In 2.1 and 2.3, the gradient is 3/4, and we notice why. Both those lines make acute angles with the x-axis, and we will just follow through to also see what the equations of those lines are. Y equals 3/4 x, y equals mx, and y equals 3/4 x for 2.3 as well. And then the gradients of these two lines are minus 3/4, and their equations are y equals minus 3/4 x. The midpoint for all four of these differ, so just check to confirm that you have them all correct. Case 3. Lines through any 2 points. We will consider a line through points P and Q. Let's observe the coordinates of the points, 1, 3 for P, and 7, 5 for Q. The vertical length, QR, is 5 minus 3, and the horizontal length, PR, is 7 minus 1. Now, calculate the distance or length, PQ. Pause to do your calculation and then to check it. By applying the theorem of Pythagoras in triangle PQR, the square of PQ is equal to the sum of the squares on the other two sides, 7 minus 1 all squared plus 5 minus 3 all squared. And we arrive at a value of 40 for PQ squared. But PQ itself is the square root of 40. Yet again explaining the distance formula. And from now on, use this formula now that you believe in it, but only when necessary, of course, as in case 3 above. Let's do the same with the gradient formula. Again, points P and Q, and as before, we will observe the length of PR and the length of QR. Note that theta is equal to the angle of inclination of line PQ. Pause while you determine the gradient of line PQ from this drawing. The gradient of PQ is QR over PR, 5 minus 3 over 7 minus 1, 2 over 6, and ultimately a third. And this confirms the gradient of our line PQ, according to our formula, is YQ minus YP over XQ minus XP. And then the angle of inclination, theta. The tan of theta is 5 minus 3 over 7 minus 1, which is 2 over 6, which is 1/3. The tan of theta is a third, enables us to calculate the angle of inclination. From our calculator, theta equals 18,43 degrees. Remembering that the gradient of the line is the tan of the angle of inclination. From now on, use the formula now that you believe in it, but only when necessary. And finally, the midpoint formula. Consider point M, and we need to determine the values of the y-coordinate of M and the x-coordinate of M. Before you think of any formula, can you guess the values of ym and xm? Pause while you do so. You probably just wrote down the coordinates of midpoint M by inspection. 4 and 4, halfway between 1 and 7, halfway between 3 and 5. We note, however, that the midpoint M of PQ has an x-coordinate which is halfway between 1 and 7, but it is also 1 plus 7 over 2, the average of 1 and 7. And similarly, the y-coordinate of the midpoint is halfway between 3 and 5, but it is also 3 plus 5 over 2, which is the average of 3 and 5. Confirming yet again the formula for our midpoint as being the sum of xp and xq divided by 2, the sum of yp and yq divided by 2. Knowing that the coordinates of the midpoint are the averages will ensure that you remember the plus signs, but whenever possible, just write the coordinates down by inspection. About the gradients of perpendicular lines and the fact that their product is -1. You don't have to know this, but was it perhaps bothering you? This slide can be used for you to think it through yourself from Figure 1 through to Figure 4. Just as a guide, though, let's see what we have in Figure 1. we have line 1 perpendicular to line 2, line 1 going through P, the point 3, 2, making an angle of theta with the x-axis, and perpendicular to line 2, forming the angle of 90 degrees. Also just note that P is being rotated anti-clockwise about the origin through 90 degrees to Q. What we need to determine, ultimately, is the coordinates of point Q and then the gradient of line 2 to prove the fact that we already know about the gradients of perpendicular lines. Pause as you take your time to observe each figure. Follow the logic as angles, lengths, and coordinates are determined. When you get to figure 2, there are 3 things to focus on: the 3, the 2, and the angle 90 degrees minus theta. When you get to figure 3, there are again 3 things to think about: the angle 90 degrees minus theta here, and the angle theta there, and the fact that not only are these 2 triangles similar triangles, because they are equiangular to this triangle here, not only do we note that these 2 triangles are similar since they're equiangular, but they're actually also congruent, because this length equals that length, so they have an equal side. When you get to figure 4, you notice 3 things: that because of the similarity of the triangles, this value is minus 2, that value is 3, and therefore the coordinates of Q are minus 2, 3. Compare these coordinates to the coordinates of P. We notice that they are swapped and opposite in sign, resulting in the fact that the gradient of line 2 is equal to negative 3 over 2, as opposed to the gradient of line 1, which was 2/3. Mission accomplished.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.